Hello everyone, so in this video I'll be explaining to you about the types of cubic crystals and number of atoms per unit cell. We know that a crystal lattice is made up of very large number of unit cells, and every lattice point is occupied by one constituent particle, maybe atom, molecule or ion. In different types of unit cells, the particles may be at the corners, at the body center, or at the center of faces. Since every unit cell in a crystalline solid is adjacent to other unit cells, most of the atoms or constituent particles are shared by neighboring unit cells. As a result, only some portion of each atom belongs to a particular unit cell. As you see in the figure, a corner atom in cubic unit cell is shared by 8 unit cells. In this figure, a face-centered atom in a cubic unit cell is shared by 2 unit cells. In this figure, a body-centered atom in any cubic unit cell is not shared by any other unit cell. Let us now calculate number of atoms in different types of unit cells. We know that cubic system is the simplest system. There are 3 common types of cubic systems. They are simple or primitive cubic unit cell. Number 2, body-centered cubic unit cell. Number 3, face-centered cubic or cubic closed-peg unit cell. The first one, simple or primitive cubic unit cell. In this unit cell, the points, that is atoms, ions or molecules, are present at all the corners of a cube. This is shown in figure. It is clear from figure 18c that atom present at each corner contributes 1/8 or 1/8 to each cube because it is shared by 8 cubes. Now, there are 8 atoms at the corners. Thus, the number of atoms present in each unit cell is equal to 8 corner atoms into 1/8 atom per unit cell. So, the total number of atoms present is equal to 1. Thus, simple or primitive cubic unit cell has 1 atom per unit cell. The second one, body-centered cubic unit cell. It has points at all the corners as well as at the body center of the cube. It is shown in figure. It is clear from the figure that there are 8 atoms at the corners and each is shared by 8 unit cells, so that the contribution of each atom at corner is 1/8. In addition, there is 1 atom in the body of the cube, as shown in figure 19c, which is not shared by any other cube. Thus, the number of atoms present at the corner per unit cell is equal to 8 corner atoms into 1/8 atom per unit cell, which is equal to 1. That is for the number of atoms present at the corners. The next one, the number of atoms present at the center of the cube is equal to 1. So the total number of atoms in BCC, which is body-centered cubic arrangement, is equal to 1 plus 1 equals to 2. Thus, a body-centered cubic unit cell has 2 atoms per unit cell. The third one, face-centered cubic unit cell. This is also called cubic closed-packed unit cell. It has points at all the corners as well as at the center of each of the 6 faces. It is shown in figure. In this arrangement, there is 1 atom at each of the 8 corners. It is clear from figure 20c that atom present at each corner contributes 1 by 8 to each cube because it is shared by 8 cubes. In addition, there are 6 atoms at the faces of the cube and each is shared by 2 unit cells. Therefore, the contribution of each atom at the face per unit cell is 1 by 2. Thus, the number of atoms present at corners per unit cell is equal to 8 corner atoms into 1 by 8 atom per unit cell, which is equal to 1. Then the number of atoms present at faces per unit cell is equal to 6 atoms at the faces into 1 by 2 atom per unit cell is equal to 3. Therefore, the total number of atoms in CCP or FCC arrangement is equal to 1 plus 3, which is equals to 4. Thus, a face-centered cubic unit cell has 4 atoms per unit cell.